Hello, my name is Crystal Santos, and I'm going to be discussing the environmental threats that Cape Cod Bay is facing, as well as examine the conditions leading to these threats and how it's affecting coastal habitats and marine species. Cape Cod Bay is a large bay in the Atlantic Ocean. It is ecologically rich with a complex and diverse array of coastal and marine habitats. Cape Cod Bay is home to many valuable species of finfish and shellfish, as well as endangered marine mammals, birds, and sea turtles. It measures 604 square miles if you draw a line from Brant Rock in Marshfield to Race Point in Provincetown. Beaches, wetlands, salt marshes, and estuaries provide important habitats for plant and animal communities. As ecologically rich and as beautiful as Cape Cod and its coastal regions are, they're at risk and they are not indestructible. The threats our coastal ecosystems are facing include pollution, habitat destruction, eutrophication, harmful algae blooms, hypoxia, and overexploitation. Cape Cod Bay is beautiful and may appear healthy, but the saltwater border that shapes our peninsula is being poisoned by nitrogen. About 80% of the nitrogen that enters Cape Cod's watersheds is from septic systems. The conditions this pollution produces devastates animal habitats and results in frequent violations of water quality standards, indicated in part by fish kills and diminished shell fisheries. Runoff pollution is another major issue impacting our coastal waters. This type of pollution is a result of contaminants picked up by rainwater and melting snow, which are eventually emptied into the bay. Examples of possible pollutants picked up in runoff include fertilizers and other lawn or garden chemicals, waste from pets, salt from roadways, and oil and gasolines leaked from automobiles. Habitat destruction is the process by which a natural habitat becomes incapable of supporting its native species. The organisms that previously inhabited that site are displaced or dead, thereby reducing biodiversity and species abundance. Eelgrass ecosystems are extremely important ecologically, and they are fundamental in structuring the natural flora and fauna. Despite the obvious value of these eelgrass beds, in Cape Cod Bay they are threatened by a number of anthropogenic distresses, which means caused by humans. Declines in eelgrass habitat have been linked to physical disturbances, such as construction, shellfishing, propeller damage from boating, and pollution. There is evidence of the destruction of eelgrass habitats in the bay by all of these mechanisms, making the health of this already fragile ecosystem even more fragile.
What is eutrophication? It's a problem that should matter to you, whether you live near the ocean or not. That's because it begins wherever people live and ends with damage to resources we all use and enjoy. It all starts when nutrients get into lakes and oceans. Remember, what's waste to humans can be food to plants and other creatures. Nutrients feed algae like they do other plants. Algae grows and blocks sunlight. Plants die without sunlight. Eventually, the algae dies too. Bacteria digest the dead plants, using up remaining oxygen and giving off carbon dioxide. If they can't swim away, fish and other wildlife become unhealthy or die without oxygen. But it doesn't have to be this way. Protecting marine resources starts with sound agricultural and waste management practices.
Harmful algae blooms, dead zones, and fish kills are the result of a process called eutrophication, which begins with the increased load of nutrients to estuaries and coastal waters. 65% of the estuaries and coastal waters in the United States that have been studied by researchers are moderately to severely degraded by excessive nutrient inputs. Eutrophication sets off a chain reaction in the ecosystem, starting with an overabundance of algae and plants. This excess algae and plant matter eventually decomposes, produces large amounts of carbon dioxide. This lowers the pH of the seawater, which is a process known as ocean acidification. Acidification slows the growth of fish and shellfish and can prevent shell formation in bivalve mollusks. This leads to a reduced catch for commercial and recreational fisheries, meaning smaller harvests and more expensive seafood. Here's a video that explains eutrophication thoroughly. Algae blooms occur primarily during the spring and summer in our coastal waters. During the spring, phagocyst blooms occur frequently in Cape Cod Bay. The negative impacts of a bloom of this phytoplankton are far-reaching, affecting the entire food chain by outcompeting other beneficial species of phytoplankton, affecting zooplankton growth and production, and being a nuisance to feeding right whales. A more well-known species of phytoplankton resulting in harmful algae blooms is Alexandrium, one of the species behind the phenomenon of red tides. Red tides have been linked to the death of fishes, whales, and humans. Blooms of the species vary greatly from year to year. Due to its life cycle of dormant cysts, Alexandrium blooms are likely to become a repetitive occurrence if conditions remain conducive, including high nutrient inputs stratification. Although there have been no documented deaths as a result of recent blooms that have occurred in the bay or the sound, the effects are still felt by the loss of income of commercial fishermen and shellfish bed closures and impacts on conch fisheries. The term hypoxia refers to low or depleted oxygen in a body of water. Hypoxia is often associated with the overgrowth of certain species of algae, which can lead to oxygen depletion when they die, sink to the bottom, and decompose. Hypoxic waters have dissolved oxygen concentrations of less than 2 to 3 milligrams per liter. Hypoxia can be caused by a variety of factors, including excess nutrients, primarily nitrogen and phosphorus, and water body stratification due to saline or temperature gradients. Closer inshore, the negative impacts of pollution are evident in the sediments. Sediments in and around harbors such as Rock Harbor and Wellfleet Harbor, which were once sandy, are now composed primarily of silty dark mud. If disturbed, these sediments release a distinct sulfurous odor indicative of areas of low oxygen. This odor comes from the production of hydrogen sulfide by bacteria which reside in low oxygen sediments. Since most organisms are stressed by low oxygen levels, hypoxic waters are usually devoid of most life. While motile organisms such as fish can leave the area, benthic organisms will be killed. Portions of the estuaries discharging into Nantucket Sound, for example, the 3 bay complexes in Barnstable, also have oxygen-depleted sediments. This had occurred in areas of Chesapeake Bay and the Gulf of Mexico, giving these areas the name dead zones. Although areas of low oxygen in coastal waters of Cape Cod Bay are not nearly as extensive as observed in these locations, these areas need to be monitored and remedied before the problem progresses. In the figure to the right, dissolved oxygen levels at locations in southern Cape Cod Bay sampled by Centers for Coastal Studies on August 3, 2021. Values less than 4 milligrams per liter are noted by the orange circles, are considered mildly hypoxic, and values less than 2.0 milligrams per liter are severely hypoxic. This is a document that was sent by the Massachusetts Department of Marine Fisheries to local lobstermen, informing them of the current monitoring of hypoxic conditions done by the Centers for Coastal Studies. They are urging the lobstermen to be on the lookout for signs of hypoxia, which includes pulling up unusual amounts of lethargic or dead lobsters in their traps. They are also recommending fishermen to check their traps more frequently and possibly consider moving gear out of the affected region to prevent trapping lobsters in the hypoxic conditions. Many mobile bottom-dwelling animals like lobsters will move to avoid the hypoxic conditions when they can, but if they're stuck in the traps, they will die as they will be exposed to hypoxia for more than a few hours. This region of Massachusetts was given the name Cape Cod because of its abundance of codfish. Today, these fish have virtually disappeared from the waters of the bay. Other species found in the bay and the sound, such as flounder, tautog, sea bass, and striped bass, have likewise suffered from overexploitation. With reference to some commercial shellfish species, overexploitation is tied directly to habitat destruction. The development of different methods of fishing to increase the catch of a declining stock has been disruptive. Hydraulic pumping for sea clams was once outlawed in the bay. Over the past several decades, however, it has re-implemented in an attempt to increase the harvesting of these clams. Here are my references, and thank you for listening to my presentation.